I have the pleasure of talking to someone from AIC, and tell us a little bit about what you guys have been doing.
Over the last several years, we've been working with Tritium and the Sedona framework in developing a full line of wireless controllers. We've had good success with the product. We've had a good market penetration and are excited to see where it's going.
Thank you, Brian. And so what was cool that we were talking about before, and by the way, I should have introduced you, Bryan Pike from AIC. Brian, you showed me something really interesting. First, let's take a look at some of these controllers. This is something that you make. What's this called?
The Bullet.
The Bullet. This sits on top of street lights, and you plug it right into the top of the street light. I guess this is kind of a rainproof type of thing. And tell us what this does.
The module is designed to replace a standard photocell. Probably 90% of your lights in the market, whether it's parking or street lights, have the twist lock receptacle that is currently being controlled either by a circuit level controller or a low-cost photocell. This device was designed to replace the photocell to give the municipality or the end user the ability to control the lights individually. Not only giving them the control functions, but also being able to monitor voltage, wattage, and current. So now you have an intelligent device that acts as a meter and an intelligent switch.
So cool, because a regular photocell, we've all seen street lights on in the middle of the day, and that's because the photocell has failed.
That's right.
But here, instead of depending on light source to be the trigger, you can just decide, hey, the sun sets at 6:28, let's make sure that all those lights go out at 6:28. The next day can be different. And then you also explained to me that there can be one photocell at the Jace overriding everything, so that if in case we do want it to be light activated in case of a storm, it can also have that option as well.
That's correct.
Now, here's what's crazy. You're telling me that we can watch in real time street lights in Chicago, and you can take me there right now?
Sure.
Let's do it.
I'm assuming at this point what's visible on the screen is visible to our viewers. But right now we're seeing live data on a city street in the city of Chicago. And if you notice the bottom line here, you can see voltage changing. We're monitoring a 240 volt circuit. Right now, because this system is set for a sunrise-sunset schedule, the lights are scheduled to be off. Of course, it's daytime. And if you see the light status here, this status is not just the command status, it's true status based off of amperage or current being read from the system. So what we'll do is...
so if that was on, it would say it was on.
That's right.
Not just because it's programmed, but because it actually would feel the current.
That's correct. And what we've got here, just to give the viewers a little bit more believability, is the fact this is the actual street we're controlling.
So if a car drove by right now, we'd see it?
That's right. There's
okay.
A guy walking right here. But this is a Cobra head street light, which is standard across the industry. And there's a decorative light off to the side here.
Okay.
Bullet 11 is residing on top of this light, right where the mouse is located.
Got it. And this is a bullet here that
That's
I'm holding
correct.
in my hand. Got it.
So if we click an override command, it's going to ask you, are you sure you wish to invoke override control? And for the purposes of this demonstration, after this car runs a stop sign, we'll give it an override command on.
Okay.
So what we'll do is when I say OK,
yeah.
You're going to immediately see the command status here change and go green, but we won't see light status change until we read current. Once we start reading current, it'll go green, and then you should be able to watch these lights come on.
This
now,
is
these,
fantastic.
These
yes.
will not be instantaneous. It'll take a moment or two, but we'll go ahead and issue the command on. It should give us a status that we told it to come on, and now light status will change. We're reading current. Now if you'll watch these lights, you'll see this bulb and this bulb heat up, and they'll be on here shortly.
Now, are they taking a second to heat up because of amperage and current, or because that's just how the light is, it's a fluorescent light?
It's the type of bulb. If it was an LED light, it would be on instantaneously. You can see now this light's going to warm up a little bit faster. You can already see it on, and if you watch the base of this Cobra head, you can see it coming on now as well. But just to speed up the demonstration, I'm going to slide the camera over just a little bit, and we'll go ahead and turn on this one as well. So we'll have two lights.
These are all being commanded in real time using this bullet, the Sedona language, which is on the Niagara framework.
That's right. This site actually has a Tritium Jace mounted on a street pole that's a half mile away from the local area network. We're using our wireless Ethernet radio to communicate that data and then wireless Sedona to command the lights. Now you can see these lights here are visibly on at this point. This one here you can see a little bit better, but you'll see the difference as we turn them off. So if we issue the override command, well, prior to doing that, we can see now we're drawing 0.7 amps at 170 watts. This is a 90 watt bulb and a 60 watt bulb. We're monitoring true wattage, so we're also taking into consideration the ballast. If this light were to go out, this wattage was dropped to around 100, which would also invoke an alarm to the end user that the 60 watt bulb is now out. So let's issue the command off, and this is where you'll see the speed of the system. If you'll watch this Cobra head, we'll go off.
Boom.
And the lights are now off.
That is fantastic.
Light status won't change until current drops. And we'll issue the command for this one. These lights will go off. They just did. Current will change. We'll then go back to schedule mode. So that way tonight when the lights are supposed to be on, they will. Now, besides just being able to log into Chicago and turning lights on and off, the system sells itself with the energy savings, because now we're able to give the end user, the customer, the ability to monitor their system in real time and then schedule lights on and off based on true schedules and save energy. We've worked a project with a mall where we've been able to pay for a system in about 1.6 years with about a 35 to 40% immediate energy savings.
That's amazing. And all that's at AIC now. You know, you're part of the Tritium family and part of, you know, the Niagara and Sedona and all of these frameworks. Where can we find you on the trade show floor, and where can we find you online if we want to find out more?
We're right across from Conference Live, booth 422, which is directly across from us. Our website is www.aic-wireless.com.
Fantastic. Bryan Pike, thank you for being with us today, man.
Thank you, appreciate it.
Really, really cool stuff.